cool, great. Yeah, I'll be using this camera because the other one doesn't really work very nice with the settings. So yeah, I don't know how much I'll be on screen either. But yeah, thank you for joining the talk. I'm Manuel, and I'm an Android developer engineer in the developer relations team at Google. Thank you so much for making it. And I'll be talking about Jetpack Compose, as you may know, and especially here about how to integrate Compose with your existing application. So we are going to see like how you could migrate potentially to Jetpack Compose and the different APIs available to do that. And so if you don't know at this point what is Jetpack Compose, so we've been talking a lot about this for the last year or year and a half. And basically, it's the new UI toolkit for Android, which is modern. It's a declarative UI, and it's completely unbundled from the UI toolkit. And what this means is that in today's world, in the view system, if we want to make an update to text view, for example, we have to ship a new framework SDK for that. We have to publish a new version. Whereas here, we could just update the code that we want and just publish a new dependency without bundling it with the core framework SDK. Obviously, it's built on Kotlin. In Android, we are Kotlin first already. And obviously, if you don't know, it's in alpha. So this moment, last Wednesday, we released alpha 05, version 1.005. And with alpha, we released a bunch of samples for you to try it out. So you can see, actually, let me show the examples. So we published 8 samples with different, characteristics, different properties for you to get some inspiration, and just trying to convince you that you should try it out, Jetpack Compose yourself. And if you're not sure about what is Jetpack Compose, or you have never seen any code for that, so do you remember, well, actually, you probably know how difficult it is to create a recycle view in the view system currently. You need a recycle view, few adapters, a view holder. This is what it is in Compose. So basically, every piece of UI is a composable function. And basically here we are just having a composable, which is called lazy column for. I'm passing in a list of movies. Now we are going to get this kind of recycle view effect. And it's lazy because it's not going to load everything at once. It's going to be smart and just loading what's going to be on the screen. So I was saying everything is a UI. If this is for the people who don't know what's Jetpack Compose at the moment, but give it a go, it's great. But today we are not going to focus about the basics of Jetpack Compose. For that, we have a lot of code labs and documentation available. We're going to talk about migrating to Jetpack Compose or how to integrate it in your app. So here we're going to kind of cover the different migration strategies that you might face, or that different company usually face when migrating to a new technology. The first one is it's a very common approach, that is adopting it in new features. So let's say you are building, in this case, because it's a UI toolkit, let's say you are building a new screen. You could start building the screen with Jetpack Compose because it's possible, and we're going to see later how to do it. Then another possibility is that you can mix and match Compose and views as much as you want. So for example, instead of creating a recycle view, as we were seeing before, lazy column for that we saw, and probably having that in a constraint layout existing in the view system. So they can interact together quite well. So fully recommend doing that as well. And then just another thing is that, let's say you have an existing application in the view system as it is right now, you can migrate the whole thing to Jetpack Compose if you wanted to. You will see that it is faster to develop and it's much easier than the view system. Obviously, this is is completely different for each project, so you have to use the strategy that works best for you. And just to give you some examples, in case you're interested, you could see these migrations could match to some samples that we have. So kind of a Compose-only screen, you could say Jet News. Jet News is the application that we had even before alpha. And here is just an application using Compose. It's Compose only, although it has some pieces together with the view system because it's still necessary. Then Crane, this is also a Compose-only application that we are going to see later. And basically here we have a map view because it's not actually available in Compose yet. So we have a map view inside the Compose UI hierarchy. And then TV, which is an application created by Chris Baines that is actually like at the moment as we speak, migrating it to Jetpack Compose. So next, this is just to give you some inspiration and some code in the future to look at in case you're interested. And we're going to see like different APIs that it's going to help you achieving all of this and enabling you to migrate to Compose gradually if that's what you want. So first, we're going to see how to have Compose in a 1600 views. And actually, Compose needs a host activity or view in order to render UI. So in case that, let's say, like the first approach, in case you want to create a new screen using Compose, like you could have a Compose code at the root of your hierarchy, and you don't need XML code. You don't need anything like that. So for example, here, you can simply extend, app compact activity, and they have the set content method in the onCreate. So set content is an extension function on component activity, and so that you call set content like this, and now you're in Compose world. You can call composables, and they will render on the screen. That's pretty neat. But then, like, obviously, this is just a very specific use case. What if you want to do something more flexible, more dynamic? And for that, we have something called Compose View, which is an actual view that lets you render Compose UI code inside it. So let's say we have, sorry, go back here. Let's say we have our fragment, which is an existing fragment in our application. And basically, we have the coordinator layout, all that there. Let's say this part here with the constraint layout, let's say we want to migrate it to Compose instead. So instead of having all the content within it as well, you can replace everything with a Compose view. And we could actually like give it the ID and treat it as any other view. And now in our fragment code, what we can do is whenever we inflate this fragment, we can get the view, we can get the Compose view, finding the ID, and calling set content as we were doing before. And now here we are in Compose land again, and we can call like composables, like a surface, text, whatever. And that hello Compose is going to render on the screen on that particular fragment. But you don't actually, like if you want to have Compose code at the root level in your fragment, as we were doing before with the activity, you don't actually need XML either at this point. So you can create a Compose view inline in this way, and that's it. So you create like on create view, you can create a Compose view with a context. And now you call set content, and there you go. You are in Compose just in a fragment. But then, of course, things can get more complicated. And let's say, like you have a more complex UI, and you need, because of some reasons, like multiple Compose views in your hierarchy. So, for example, here we have a linear layout, and we want to add a couple of Compose views with a text view in the middle. So here, you don't have to forget about unique IDs. And this is because the unique IDs are needed in order to make your saved instance state. So we will see later that with saved instance state, you can restore your state across process death and all that. And so in order for that to work, this needs to have unique IDs, the Compose views. Cool. Nothing else here. If you want to have Compose in your system UI view system code, just call Compose view or doing like that. That's it. No more. But now let's see the other way around. Let's say like now we are in Compose and we want to have an Android view inside it because you want to reuse your custom view that took you so long a couple of months back, or you want to use views that are not yet offered in Compose. So for example, like a map or a web view. So in that case, you have the Android view composable. And it's a composable because this needs to be called inside in Compose code, basically. And if we take a look at the function name and the attributes, here you will see you have the view block. That is basically like the view factory. This is going to return the factory. This is going to return the view that needs to be rendered in Compose. And then you have the update lambda. That basically it's a callback that you get when the view is being rendered on the screen, and you can make updates. Cool. So for this, we're going to see our examples. As we saw later, we have Crane. And this is one of our sample apps. And this is a Drawable app that part of the material studies as well. So here, it's going to show you a list of destinations. And when you tap on one of them, it will take you to this details screen. and it'll show you the map. But the map, it's actually from the Google Maps SDK for Android library that doesn't have a composed version of it yet. So we have to use Android View in this case. So now let's say we want to create our composable, our reusable piece of UI that we call map view container. We create a map view. This is our code that we will see later, calling remember map view. This is just giving the actual map view itself constructed. And we're passing to Android View, kind of the factory here with the Lambda we're passing in because we don't want to do anything weird there. And then we get the update callback. And now in the update callback, like we could have code as if we were in an activity or view. So in this case, we call get map async on the view as the Maps SDK documentation says. This is how we configure the map. And that's it, like we add a marker, move the camera, and nothing else to do. And we have the map view on the screen. But what's even better about this is that you can also interact with the view, as you can see in the gift, and communicate between views and compose seamlessly. So what we are doing here is that we have the zoom control buttons below the title of the screen. We have the zoom controls buttons written in Compose. And then the map view, which is a view itself. So you can see like how we can update it from Compose, and we can interact with the map view and move the map around. So that's great in order to integrate your application with Compose. So how are we going to do this? So basically, we have the same code as we had before, and now we are going to add this, the zoom state that we are using with saved instance state, just to restore it about, if in case the activity recreates or whatever with initial zoom, and then we have the zoom controls, which is just the plus and minus sign that we saw before. That is going to control that zoom. And so now in our update lambda, we can read the map zoom and call in set zoom in that. So here, like this code might be a little bit weird because in the update lambda we are calling another lambda, and so the read of the state needs to happen inside the update lambda. That's why we have that variable called map zoom. And that will be it. And whenever that map zoom changes, whenever zoom changes, it will recompose the Android view and will actually set the correct zoom on the screen. But this is obviously if you want to create views in line, as we are seeing here. We were creating the map view in that remember map view function. But what if, for example, you have XML code? For that, we have the Android view binding composable. And this ships in a different artifact in the UI-view binding, because not everyone needs it. And of course, this requires view binding to be enabled. So basically, simply call Android view binding with the inflation of the binding of your layout as a parameter, and you can access your bindings in the update lambda. Nothing else to do here. The next topic I'm going to talk about, it's about resources. Of course, when you are in Compose, if you are in an application using both the view system and Compose, you might need to access some resources from the view system. And we are providing helper methods to do that. So for example, for strings, we have the method string resource, and then you can get the label from your string XML file. And then if you need something more complicated, like positional formatting, you can do that too. It's as easy as that. Then plurals, it is not supported straight away. And then here, as we will see later, we have some sort of escape hatch. So we have this, the way, as we will see later, the way to access the view system in a very raw way. It's using ambience, and here, for example, to get the resources, we can access using context ambient.current.resources, and then as we will see here, and then you can call the get quantity string method, because it's not at the moment. I think I filed a feature request for this, but it hasn't been implemented yet. So you can do it yourself with this kind of escape hatch. Use it with caution, because of course, you can get into problems down the line. Then it also works with dimensions. So you have the dimension resource method, as you can see. You have color resource. You can see the trend. It's pretty much the same, quite easy to do. But then also we have, in order to draw drawables on the screen, there is a difference between vectors and bitmaps. So in the view system, like they were pretty much the same with the same methods that you could access, but in Compose, these have been like separated out. So in order to have a vector resource, for example, coming from an XML, you have the vector resource method. And then for bitmap, you have the image resource, for example, if you have a PNG or something. So there is not a common way to load this. And the thing here is that these functions are happening, like the decoding and parsing of the vector and bitmaps are happening on the main thread. And actually, this is how it works in the view system. Like there is nothing we can do there. But in Compose, we have opportunity to do this in a new way. The new features, or actually the new APIs to load these functions from the background thread, is using something that we call load image resource. So it's like the load something method here, and actually these are gonna load on the background thread, and what you get is a deferred resource that you can actually check later. So if my image has been parsed, for example, then display that on the screen. Otherwise, skip it or put it blank or whatever. And because of the magic of the recomposition, that deferred image is gonna update automatically when the image has been loaded. And so this composable, if you use this in a composable, it will recompose automatically when the view has been loaded. And the same for vector resources. So you have the load vector resource function that is also gonna load it on a background thread. Cool. So I introduced the next topics a little bit before. Let's say, like, if you want to call the view system from Compose, right? I said that there were some escape hatches. So, for example, and those escape hatches are with ambients. And an ambient, it's basically kind of like a service locator thingy, where, like, at some point you can update them in parts of your hierarchy to get a new value. So, for example, if you use context ambient, you will get the context in that particular part of the UI tree. And that's if you need the context, but also you can get the view ambient in case you need the actual view for some reason. The lifecycle owner ambient configuration in case you need to know if you're in landscape or portrait, things like that. And so, as I was saying before, use this with caution. And before, as well, we left one function unimplemented. And that function was remember map view. So we're going to see how to do this. And actually, this function, the idea was that it was going to return a map view. So we're going to see how to put these ambients that I was talking about in practice. So in order to create a map view, like, you need the context. And so, like, we were like seeing before as well, that by calling the context ambient.current, now here we're going to get the context. This is easy. But the problem with the map view is because it's a map view from the view system, it's a view from it's an actual view, to be honest. Then we need to give it a life cycle. So we need to make it, we have to make it go through onCreate, onPause, etc. So how to do that with Compose? So probably the naive way of doing this is trying to get the Compose lifecycle to do that. And so here we have some functions. By the way, do not do this. This is a very naive implementation, and it's actually wrong. So we have onCommit that will be called every time that the map view changes. When the composable is in the composition. So we could say, like, hey, the composable is in the composition now, it's going to be rendered on the screen, so we can call onCreate, onStart, onResume. Hey, happy ending. And then when the composable is going to leave the UI in onDispose, we can call onPause, onStop, onDestroy. Obviously, that's not going to work as we expect. In some ways, it's going to work, but it's not a great solution, right? Because imagine here, you're just forcing the view to follow the Compose lifecycle, not the actual view lifecycle. So the thing that we can do here is integrate this map view with the actual view lifecycle. And so for that, we can use the lifecycle owner that we've seen before. So here, what it creates, it's a map lifecycle event observer that we are going to see the implementation in the next slide. This is just an event observer that is going to control the lifecycle of the map view. And now, basically, what we can do is calling the lifecycle just to make it adjust to the actual view lifecycle. So we can grab the lifecycle owner in this case, like let's say we're in a fragment, for example. We want to follow the fragment's lifecycle. So whenever that happens, when this composable enters the composition, enter the UI, we can call add observer, the observer that I created before, and then when it's going to leave the composition, I want to remove that observer. And that observer basically is just this piece of code where, like, given a map view and given a state in the event's lifecycle, then I'm going to call onCreate. And as I was saying before, this is going to follow the view's lifecycle instead of the compose thingy lifecycle. That it is kind of a pretty bad idea, to be honest. So if you want to do something like this, check this out. It's also in the documentation. Cool. So now we're going to see another topic. And that topic is the app architecture. So let's say you migrate to Compose. What happens with the architecture of your app? Do you have to change anything? The reality is that you don't really have to change anything if you don't want to, because Compose is working on the UI layer of your app. And so the rest of your architecture can remain exactly the same. And now the way that it changes is like how Compose interacts with the closest layer to the UI, which could be like, for example, the view model layer. And for that, we are providing helpers as well. So for example, for the view model, we are creating this view model function with which you can call like architecture components view models in your composable. So that's pretty handy. And this is going to return an existing view model, or it's going to create a new one in the given scope. So here, for example, and the scope, like it will be, this view model will be retained as long as the scope is alive. So for example, if the composable is used in an activity, a view model will return the same instance in all composables until the user moves away from the activity or the process is killed. So let's see how to put this in practice. So here, imagine that we have the same function as before. We have the same example, sorry. We are using Crane. And in Crane, we have this main view model that is just going to give us a list of destinations, for example, suggested destinations in this case, using a live data. And so how can we get this view model from our main composable in Crane? So for example, it's as easy as this. So for example, in here, in Crane home content, it's our composable, you can grab an instance of the main view model by just calling the view model function. That's it. In case that you need a factory or something, the view model function also takes in the factory if you need to pass dependencies to it, for example. We don't have to do anything else. We can start like using the view model, for example, if the user clicked a button or stuff like that. So we were seeing before that the view model, it's using live data inside it, but Compose not only provides a helper functions for live data, but also for flow and observable. So Compose comes with extensions for all of these, and each of them are going to be available in their own artifact. So basically, when you do this, calling like observe a state or collect a state or subscribe a state, these functions will register as an observable in the live data flow observable and will represent the values that they emit as a state. So every emitted value will cause a recomposition in those places where the state is used. So in the following example, in Crane, we are going to use the live data extension. And that one is available in the runtime-live data artifact, as you can see at the bottom of the screen. So back to our example, we had our view model there. And because the view model exposed the suggested destinations, we can call it. We can do a view model, the suggested destinations, dot observe a state. And now we assign that to destinations. So that's basically going to be in the lookup for new updates. And whenever, for example, we call the explore section and we pass in destinations, whenever destinations change, if, for example, explore section reads the state, it is going to get recomposed whenever there is a new value emitted into the live data. So that's very handy. So this is with live data and view models, but we're going to see how to actually use a saved instance state that we saw a bit before. So basically, apart from restoring the state whenever the composable is going to recompose. This is also helpful if you want to survive the activity or the process being recreated. So, for example, as we saw before, there are functions that you can do for strings, for example, to save this string, or any data type that can be bundled is going to be saved automatically. So, for example, an int or a float. But if you want to save a more complex data structure, you have different options. So imagine that we have this city data class with name and country that we want to save. So the simplest solution is just to use the parcelize annotation. In this way, the object is going to become parcelable and can be bundled. So you can call, save int and state, and you can pass in the city straight away without having to do anything. But if you want, for example, you don't want to use parcelize for some reason, or you want to do your custom thing, you can do the same using a saver, where the saver, you're going to convert the object into a set of values that the system knows how to put in a bundle. So in this case, we are using a list saver. So this is basically, it's going to let Compose know how to convert a city object to a list of strings values. And then in the restore lambda, what we are going to do is describe how to convert this list back to a city object. And now in the save instance state method, you pass in the saver, and now you can save the city as you would normally do with other objects. So that's pretty interesting. Cool. So now we've written a lot of code in Compose, but what happens with testing? So testing is obviously indispensable to verify that you haven't broken your app if you are migrating or you are creating new things. So to test Compose-only code, you have to use the create compose rule in your instrumentation test. So the way you use it is that you put that as a rule in your test, and that's it. You don't have to do much more. And here you have whenever you want to test a specific composable, for example, explore section, we include that, the composable under test, under the test rule set content, as if we were calling it from an activity or fragment. And that's it. And then when you do that, you can start testing that composable using the Compose testing APIs. So in this case, for example, in the node that says Madrid, Spain, I want to assert that's being displayed. But also, you can also use Espresso for the view system. You can use both frameworks at the same time to test the application. So for example, if we wanted to test that the view, the map was on the screen, we can use Espresso APIs, as you can see on the screen. And the thing here is that Espresso is going to wait for Compose to become idle. So they are like in sync, they are communicated, and they are working perfectly fine. But what if we wanted to test something more complicated? What if we needed the activity rule in this instrumentation test? For that, you need to use the create Android compose rule instead. And basically you use it in the same way. So now you have the test rule, create Android compose rule, and now this gives you access to the activity rule, and then you can access the scenario. So for example, in this test, we are checking that the camera position that we moved before is at the right spot. So here in the onActivity callback, we can check what is the camera position where we are at, and then after that, we can assert that the camera position is at the right place. So for this, as I was saying, you need to use the create Android compose rule instead of the create compose rule. So you need the extra Android word there. Cool. We're going to move on to another topic after testing, something that is work in progress, which is the navigation library. So there are a lot of questions about navigation and in the community, and this is because at the moment we don't have a formal opinion on what you should do with navigating while navigating in your app. And so this is a work in progress. As you can see, the version is not actually released with the rest of the artifacts. You need to use a snapshot version of this library. And pretty much it's work in progress, as I was saying. But just to take a sneak peek of what's going on here, we're going to see the different APIs and how that's going to look in the future. So we're going to see that the main API is the nav host composable that is going to create a new navigation graph inside Compose. And the way to add destinations to that graph is using the composable function. So here in that you create like destinations that can take that composable as a destination. So in this case, profile, dashboard, whatever. And then you can also, of course, pass the start destination just to tell the host where to start the graph. But then it could get like you can make it more complicated if you want. For example, to get the full control of the navigation graph, you can pass in this nav controller, and you can remember it and pass into the nav host. And with the nav controller, you can use the navigate function to navigate to another destination. So with this, you have full control of what's going on. But imagine that now here, because we have the nav controller at the same level, but let's say you are in the navigation, you're using the navigation library, and you're in a very nested composable, and you want to access this navigation controller. So actually, we are also providing an ambient nav controller to actually get the instance of the closest navigation graph. And so with that nav controller, you can navigate wherever you want to go. You can see here, we are not taking any dependencies as a parameter in the saved function. Cool, as I was saying, this is pretty much work in progress. There are a lot of things coming soon to the navigation library. Nav support to pass dependencies to the nav host. Actually, I think the CL that contained this code was merged a couple of days ago. So this is like coming as like the guys are developing this this library as we speak. It's coming very hot. Then we're going to have support in the future for saved view state to pass state as part of the backstack and to restore it. And also deep linking support will be coming in the future. Cool. Another topic to talk about is what happens with your themes and styles. Of course, you spent a lot of time trying to see our recommendation, which is the material theming, which has a typography, shape, and color. So what do you do with all the time that you spent like tweaking those values? The new recommendation as well is using the material components for Android libraries, MDC, that we are going to call it from now on. And that's basically the new material design libraries that are available in Android. But things in Compose work a little bit differently. So for colors, you have this, you have basically a composable that is going to give you the colors of your app. So you can assign, for example, the colors with dark and light colors if you want, and you can pass in the primary or secondary colors. For example, here we are creating a palette of colors that it's green and black. Right? And then these colors you can pass to a material theme, which is another composable. And basically, this is how you would create a compose theme yourself from scratch. You call the material theme if you want to extend from it, and then you can pass in colors, typography, and shapes. And then inside it, you can call other composables that will use the theme declared above. But then, of course, in your view system, you might have something like this. So this is something, XML code taken from the Google I/O application, and we have a very large theme settings there with text appearances, shapes, etc. But now, if you want to start migrating your app, you will see that you might have to replicate the same kind of things in Compose. So at some point, you might have multiple sources of truth. And that's actually not ideal. It is not necessarily a bad thing. It depends on how long or how much you want to be supporting both systems. But at some point, if you consider that Compose is your source of truth, you will have to move everything to Compose. So if that was the case, ideally, you would have your theme in Compose that then you could use in your view system. But this is not possible at the moment due to the limitations of the view system, because you cannot create themes at runtime or dynamically. Everything needs to be static in the XML. So instead, we published a new library called MDC Compose Theme Adapter that you can use your view theme, your MDC theme, as the source of truth. And that's going to read your colors, text appearances, shapes, etc. And so what's happening here is that it works the other way around. So you have your theming and your settings in the view system. And basically, instead of replicating the same in Compose, you just call MDC theme, and that's it. And that's going to read everything that you want. but also it gives you the possibility to tweak some values. So for example, if you want to use most of it and then tweak something like the colors or something, like you can call the create MDC theme as instead, passing in the context, and here you will get the colors and types and shapes read from the view system. Now you can tweak them and pass them to material theme if you want to. So there are a few limitations with this, is that it only works with MDC. Of course, no, it doesn't work with app compat or platform themes. It's gonna only read the color, text, and shapes, and it is not gonna read the default widget styles. That's because there is no concept of a default widget in Compose. We will see later how we could, get around that. And it's only gonna modify the theme, only works in Compose. So if you want to tweak the values as we did before, that's only going to work in Compose, not in the view system. And it doesn't handle window attributes either. So you will have to do that yourself. So what happens with the widget styles, as we were saying before? Like if you have your fancy button, now fancy button style, how you could have that in Compose instead? So here we have our custom button where we are giving a stroke width and stroke color. Again, like we don't have that sense of custom default widget style in Compose. So how to do that? In Compose, instead, you will have to create a new composable function that is reusable. So it's pretty much the same. So you can create your My App button, and then, for example, this is going to be what you call in the view system, widget My App button. Now it gives you the name. Because it's a button, you have button as the parent style, and now you can configure it passing in the border, and that basically is going to create your reusable button. Cool. Quickly, that I'm kind of running out of time. It's fonts. FYI, fonts are not downloadable. Fonts are not available in Compose, so you have to embed them in your app and then call stuff. And then for image loading, we have a new library, Accompanist. I'm gonna leave some time for questions. So image loading, check out this Accompanist library that is gonna give you support for Coil and Picasso. So I'm gonna skip this. Some resources, migrating to Compose Code Lab, we have TV, Sunflower as well in Compose, and then what we've seen before with the Compose samples and code labs and all that. So thank you so much for your time. 3 minutes for questions.